Okay, so now that we've discussed fossil fuels and nuclear energy, we are going to focus in lecture 4.4 on renewable energy and sources of renewable energy. And just like we did for fossil fuels and kind of for nuclear, we are going to look at the nature and origins of renewable energy and where we are at still in terms of environmental impacts, social impacts, etc., of renewable energies. So, the renewable energy that we are going to be looking at in this class, in this lecture today, we're going to focus on 5 forms of renewable energy: solar, wind, hydro, geothermal, and biomass. Those are the most dominant forms right now of renewable energy. There are other forms, but they are much less mainstream, scaled up to mass production. So, we're not going to focus on them today. So, in general, renewable energy or any energy resources that can be easily made, easily renewed, are available to us. Um, we are not going to run out of whatever it is that is used to generate the energy. So, we can never use up renewable fuels. And as I've said, the most common types of renewable fuels are hydro, solar, wind, geothermal, and biomass. Some of these are, a lot of these are things that you will have heard of before. Some of the specific technologies, even within solar or wind, you may not have heard of before. So hopefully you'll become aware of a few things that you were uh, previously unaware of. So solar energy is obviously energy that we get from the sun's rays. The light rays that come down to the earth from the sun contain energy, solar radiation that reaches the earth, and that can be used in a variety of different ways to um, be converted into other forms of energy. So we can take the energy, the solar radiation that's coming down that reaches the earth, we can convert it into heat energy, electrical energy. And this is technology that isn't necessarily, or this isn't a concept that's necessarily new. We've been using the sun to cook and heat food in homes for lots of things for many centuries, really. But what we are doing now that we haven't done before is using it to, in more advanced societies, to heat our water, to heat our spaces, and to generate electricity. And we're doing that by actually converting the solar energy into electricity. And you guys are familiar with this. Those of you who were our interior design students have perhaps looked at solar energy a little bit more than our apparel and textile students have. But basically, we have 2 ways in which we can convert solar energy into electricity. We have um, photovoltaic devices, PV devices, they're sometimes referred to. And these are cells that change sunlight directly into electricity. These are often used in more remote locations that are not connected to an electric grid. So they are standalone. They're basically what we use in our calculators. So if we have a solar powered calculator, that's a photovoltaic cell. They're used to power watches, road signs, things like that. Anything that's not connected right into the electric grid. And then we also have solar power plants. And these are going to indirectly generate electricity when the heat from the solar thermal collectors is used to heat a fluid, which then makes steam, which is then used to power a generator. So a very traditional way of generating electricity, just using the sun to heat up the steam instead of coal or gas or something else to heat up the steam. Um, these are more of the traditional forms that you are familiar with and that you have seen on homes. Some of you maybe even have solar power on your homes, who knows? Um, this picture actually totally sort of blew me away when I did a search for it. Um, we are starting to get very large solar energy farms throughout the world. This particular one is one of the largest ones that we have. We are also starting to see solar panels be placed, floating on water, placed on, um, you know, oh, just all sorts of things like in parking garages and things like that. Um, as far as the environment is concerned, obviously solar energy does not produce air or water pollution or greenhouse gases. So in that sense, it's carbon neutral. We are not contributing to greenhouse gases when we generate solar energy. However, that's not to say that there are no negative impacts on the environment. For example, there can be toxic materials and chemicals used to actually make the cells that convert sunlight into electricity. Some solar thermal systems use fluids to transfer the heat, and sometimes the chemicals in those fluids can be dangerous, although here in the United States we have fairly strict environmental laws that regulate all of that. Um, Now, the other aspect of it, as is with any type of power plant, they can affect the immediate environments near their locations. You have to obviously clear land to construct the farms, and then you are taking up land that could have been used for habitats for native plants and animals. Um, Sometimes solar plants require water in order to clean and cool. Um, and so using large volumes of groundwater or surface water sometimes affects the ecosystems that are dependent on those. So um, there are pros and cons, although of course the pros far outweigh the cons at this point. So we are going to see continued development of solar energy into the future. So wind energy. Wind energy here in Kansas, we are well familiar with. Kansas is one of the top producing wind energy states in the United States. Um, Wind creates energy just through the natural, the natural turbulence that's in the air, the air that's in motion. Um, it is energy that can be stored. And most wind energy nowadays is used to generate electricity. And of course, we know that it's renewable because as long as the sun shines, the wind is going to blow. That's just basic weather. In 2016, we had 40 states in the United States that had large scale wind power projects. As I said, Kansas is one of the top producing ones. Texas, Iowa, Oklahoma, Kansas, and California are other large wind producing states. They generate, those 5 states, about 55% of all wind electricity that's generated in the US. And we just happen to live in an area of the United States that's sort of a wind tunnel. So it's very ideal for producing wind energy. Um, we have seen in recent decades a push at the US federal government level to establish incentives to develop wind energy and to use wind energy. So the federal government has policies just like they do for coal and for natural gas, etc. They have over the years funded research and developed projects to help build less expensive wind turbines, because wind turbines obviously can be very expensive. They've offered tax incentives and other tax breaks and investment opportunities for wind power projects. And all of that has really helped increase the number of wind turbines that we have available to us. And I've actually talked to some of you about this already in the discussion forum, but here in Kansas, if you have your energy supply, your electricity paid for by Westar, if that's who's providing your electricity, you can contact them and get 100% of your household electricity come from wind energy sources. And it's very, very cost difference. So our house, which is about a 2,000 square foot house, it costs us about $1.75 extra a month to have our electricity come from wind as opposed to coal. Very easy to do. As far as the environment is concerned, it's obviously a renewable energy source. And overall, using the wind to produce energy has far fewer environmental impacts than many other energy sources, including renewable energy sources. Wind turbines don't release any emissions that can pollute our air or our water. They do not require any water to cool them. They do not require chemicals to operate. And so as a whole, they are a very positive source of energy. An individual wind turbine has a relatively small physical footprint, so they take up less space than like solar panels do, for example. And when we have these large groups of wind turbines or wind farms, they're often located in open land that's being used for farming, or they're on mountain ranges, or they're offshore in lakes or oceans. So they're not destroying habitats that would be used for other purposes. Farmers can oftentimes continue to farm around the wind turbines. Um, they are sometimes criticized for the visual impact that they have on the landscape. I personally think it's beautiful to drive through western Kansas and see all of the wind turbines on the horizon, but some people don't like how they look. Some people think that they are loud. Um, they've also been criticized for causing bird and bat deaths. So you know, there's pros and cons. I would say probably the deaths that we have seen, the bird and bat deaths that we have seen from wind turbines are probably lower than the bird and bat deaths that we've seen from the destruction of habitats for other forms of energy production. And there are scientists that are trying to figure out how to build a turbine that actually doesn't, um, that is less likely to kill birds and bats. This picture right here is what a traditional dam is going to look like, sort of just using the water that's flowing through the dam. There are other forms of hydropower. You can use tides and the high tides and the low tides in the movement to generate electricity. You can use, which is the picture on the left. The picture on the right is of wave power. So you can have these power generators out in the ocean, and the waves and the oceans movement and heat can generate electricity as well. So there's a wide variety of technology available for hydropower. Okay, geothermal energy. So geothermal is basically heat from within the earth. We can use the steam and the hot water that's produced inside the earth to heat buildings and generate electricity. It's a renewable energy source because the water is naturally replenished by rainfall, and the heat is continuously being produced from inside the earth. So we're using the heat that's already there to generate electricity. So basically, about 4,000 miles below the surface of the earth is our core. It's hot, hotter than the sun, in fact, and we can use that to, we can draw on that to produce steam and generate electricity in sort of the traditional manner in which we can do it. Um, People around the world use geothermal energy to heat their homes, to produce electricity. They basically dig really deep wells and they pump the heated underground water or steam to the surface and use that for electricity purposes. Most of the geothermal plants in the United States are in the West and in Hawaii. Because that's where we can access geothermal energy resources. They're close enough to the surface of the earth that we don't have to dig a well that goes down 4,000 miles, obviously. California generates the most geothermal electricity. And the United States actually leads the world in geothermal electricity production. The effects of geothermal energy on the environment really depend on how it's been converted into energy. Um, in and of itself, it really almost has no negative effect on the environment. They have low emission levels. They do not need any fuel to generate electricity. They don't. So that means they're not emitting sulfur, which is causing acid rain. They're not emitting carbon dioxide for climate change and greenhouse gas emissions. They're fairly clean, and in fact, they can have a very positive impact. Um, so the key though is that you need to have access to this geothermal energy from the earth in close enough to the surface that you can access it and utilize it. All right, and then finally we have biomass energy. Biomass is any organic material that's been made from plants and animals. It contains, again, stored energy from the sun. So plants absorb the sun's energy through photosynthesis. Then we have a chemical reaction in the plants that gets passed on to the animals and then the people that eat them. And the biomass is a renewable energy source. So it's going to always grow. We can grow more trees, we can grow more crops. There's always going to be waste that's going to exist. So examples of the most common types of biomass are wood, crops that we can burn, manure, and some garbage are what we most commonly see. And what happens is there's this stored energy in the biomass, and then you burn it. And when you burn it, you release that stored chemical energy is released as heat. And so you know this. You have a fireplace. The wood that you burn on it gives off heat. That is a biomass. You can burn garbage to produce biomass, and you can burn garbage, which then can be used to heat steam, which can then be used to make electricity through very traditional electricity generating. You can also, though, take biomass and you don't have to burn it. You can take it and convert it into other forms of energy like methane, or you can turn it into transportation fuels like ethanol and biodiesel. So it's the same idea, it's just you're not directly burning it, you're turning it into something that then can be burned. Methane is the main ingredient of natural gas. And so we need it if we're going to process natural gas. We can take crops like corn and sugar and we can ferment them and produce ethanol, which is a transportation fuel. So there's a lot of different things we can do. Biomass fuels provide about 3% of the energy in the United States. And here in the US, we are trying to develop new ways to make and burn and use biomass and so that we can use less fossil fuels. As it can be a way to cut back on waste and also support agricultural products in the United States because a lot of our biofuels come from corn and other agricultural products. So as I've already said, wood is still the most common form of biomass, and we've been using it for thousands and thousands of years. It continues to be a major source of energy in much of the developing world. Here in the United States, we're not likely to use it as much to heat our homes, but some people are still reliant on it. And then another common form of biomass would be a municipal solid waste. So garbage, essentially. Trash that comes from plants or animal byproducts, food scraps, lawn clippings, leaves. Those are all examples of biomass trash. And there are facilities out there that will burn biomass and turn it into electricity. It's not common in the United States, but it happens. It's more common in other countries. And it's also pretty common in Hawaii, actually, is burning biomass. And then I also said that another form of biomass are biofuels, and these are our transportation fuels like ethanol and biodiesel, and they are made from biomass material. So these are an alternative to diesel, um, compressed natural gas, and gasoline. Other ways, cleaner ways to operate vehicles. Um, they're usually blended with petroleum fuels, so our technology isn't really to the point where we can have a car that runs on 100% biodiesel or ethanol. They're often blended with gasoline and diesel fuel, but they can be used on their own under the right circumstances. But by using ethanol or biodiesel, it just means that we don't have to burn quite as much fossil fuels, and they're cleaner, so we're not producing the air pollutants. Ethanol and biodiesel are usually more expensive, and the vehicles are usually more expensive too. So ethanol is an alcohol that's made from sugars that's found in grains such as corn and wheat. And farmers and researchers and scientists are experimenting with different ways to grow and process these things to turn them into ethanol. Um, Biodiesel is made from oils and fats, such as recycled restaurant grease, and they can be used in actually a diesel engine without even changing them. So you can burn biodiesel in any diesel engine car. It's the fastest growing alternative fuel in the United States. It's renewable, it's safe, it's biodegradable, it reduces air emissions, etc. Um, Ethanol is non-toxic. It's good for the environment in that way. It 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 can be spilt on the ground and it's not going to damage ecosystems. Um, it 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 definitely burns cleaner. Ethanol does than gasoline. Um, they are going to emit far fewer greenhouse gases and other types of dangerous chemicals. Um, but they're actually considered, even though they do emit some greenhouse gases, ethanol is considered to be carbon neutral because when you grow the corn and the sugarcane, which are the two most common ways of making ethanol, when you're growing them, you're absorbing as much carbon dioxide as you are releasing when you're burning them. So that's why it's kind of considered to be carbon neutral. Um, there, in that sense, ethanol is fairly positive. The United States government is supporting efforts to produce ethanol because it supports farmers and agricultural manufacturers in the United States. There are still controversies over ethanol. There are people who argue we should not be using farmland that could be used to grow food, to grow fuel. And there are still, it's still, you have to grow a crop in order to get the ethanol. So you're still having to use water and fertilizers and other inputs to get the corn and the sugarcane to grow. So it's not without its environmental impacts. Biodiesel, as far as it's concerned in the environment, it's considered non-toxic, it's biodegradable, it burns clean, and it reduces greenhouse gas emissions. Again, it's considered to be carbon neutral um, and fairly positive for the environment. All right. As far as renewable energy is concerned in general, so not just for a specific type here, this will show you all of our energy consumption by source in the United States. Petroleum, oil, natural gas, coal, which we've talked about, nuclear power, which we've talked about, and then about 10% of our energy in the United States is generated through renewable resources. And you can see out of that 10% how it is divided out. And where it's coming from. Hydroelectric, wood, biofuels, bio waste, wind, solar, geothermal. Um, and that's on a nationwide basis. Now, as far as countries who are leading the way are concerned, these are our top 10 renewable energy producing countries in the world. Um, And some of these countries are doing pretty amazing things. Like, for example, in Sweden doesn't use fossil fuels inside its country anymore. It has drastically ramped up investment in solar and wind energy, and they are um, truly working to be the first 100% renewable energy country. They're not quite there, but they are have this goal of being 100% carbon neutral, fossil fuel neutral, 100% renewable energy within a decade. So, if you are curious about any of these other countries, sometimes it's surprising, like Nicaragua. You would not expect them to be on the top 10 list. Um, Oftentimes, these countries are small countries that do not have a lot of fossil fuels within their own boundaries. And so they are reliant on other countries for their oil, their coal, and their gas. So they have a lot of motivation to switch to renewable energy sources. The United States is on the list. We are in the top 10 of countries that are using renewable energy. Um, in the United States, we are doing a lot with solar energy, a lot with wind energy, um, and the solar industry in the United States now employs 3 times more people than the coal industry. So we're doing a lot. There are, though, some concerns that we are going to see a slowdown in renewable energy production in the United States now that we have a new president with new priorities. So um, there's a lot of really great things happening. Like for example, this March of 2017, for the first time in U.S. history, was when we got to just above 10% of all of our electricity coming from wind and solar. Um, so this was a new milestone. We were very excited about it. But there are concerns that if our government is not invested in renewable energy, we are going to see a slowdown in our shifts. Um, so it's hard to tell exactly what's going to happen. Keep your eye on the news and your ear on the news. We have this coalition of cities that are actually pledging to make 100% renewable energy a top policy priority for their cities over the next decade. So there's this coalition of cities called the U.S. Conference of Mayors, and they actually represent 148 million people within the United States live within these cities, and they use about 40% of all the electricity within the United States. And what they are doing is, as mayors and as our cities are saying, we are committed to, as a city, being 100% renewable energy powered. And so, even if our federal government isn't committed to renewable energy, if the cities are, we could see a major shift in what we're capable of doing and where we can get our renewable energy sources from. Um, so that's something to keep your eye on. I think they were voting on that this week. So just if you're curious, do some Google searching on where we're at and what's happened with that. Um, Renewable energy jobs are growing around the world as prices for renewable energy falls, and we see an increased interest in clean power. So worldwide, 9.8 million people are now employed by the renewable energy industry, and it's booming in many countries. And here in the United States, we've seen explosive growth in renewable energy jobs over the last 3 years. Solar is leading the way. Wind energy jobs are up drastically as well. And we are, as we've said, employing more people now in renewable energy than in the coal industry. However, we're still falling short of what other countries are doing, and that is the fear that we're going to continue to fall more and more behind if our federal government is not in favor and support of this.